2.7, last section of chapter 2, and we're going to practice graphing rational functions. We've talked about how to find vertical asymptotes, how to find holes, how to find horizontal asymptotes, how to find zeros. Now we're going to practice graphing, and we're going to throw it all together today. Yes?
Will this be on the homework copy tomorrow?
This will not be on the homework copy tomorrow. Good question. No, it will not be. All right, so we have a rational function, let f of x equal to some polynomial on the top divided by some polynomial on the bottom, same thing that we've been talking about before. Remember, rational functions or rational numbers are numbers that can be written as a fraction. So rational functions are functions that can be written as a fraction. So you have a polynomial on the top divided by a polynomial on the bottom. This is what you need to do. Step number 1 is you simplify it if possible. So in other words, you factor the top, you factor the bottom, try to cancel things out if you can. You guys have done this already, that shouldn't be a big deal. The second thing that you need to do is find and plot any y-intercepts that you might have. And you find y-intercepts by replacing the x's in the rational function with 0. So I just go through, I plug in a bunch of x's, replace all of my x's with 0, I get an answer. Okay? Shouldn't be a big deal. The thing that you need to remember, though, is that when you're calculating that, when you're doing finding the y-intercepts, you need to plug zeros into the original function. Don't plug them into your simplified function, okay? Go back to your original function, calculate the y-intercept, plot it, and then move forward. The third thing that you need to do is find the zeros of n of x. Those zeros of n of x, what does that mean? N of x.
Numerator.
Numerator. Find any zeros on the numerator, if there are any. And those numbers, those values, are going to be your x-intercepts. Then you plot them, okay? And you'll have these steps in front of you, so you'll be able to use them when you're trying these problems today. But find the zeros of the denominator, if there are any of them. Those are going to be your vertical asymptotes, unless there happens to be, actually, we're looking now at the simplified function. So anything that's left on your denominator, anything that will get you a 0 on the denominator is going to be a vertical asymptote. We've talked about that already. Then you sketch the vertical asymptotes using dashed lines. Vertical asymptotes obviously are vertical lines, and usually you graph them with a dashed line, not with the solid line. Otherwise, it looks like the solid line is part of the graph. All right, the fifth thing that you need to do is find and sketch the horizontal asymptotes using dashed lines. How are you going to find the horizontal asymptotes? Oh, how are you going to find the horizontal asymptotes?
Find the degree of the
Yeah, using those 3 rules that we talked about in the last section. Good. Yeah. Remember, if the lead coefficient, or if the degree of the numerator is the same as the degree of the denominator, it's the lead coefficient divided by the lead coefficient. If the numerator is bigger than the degree of the numerator is bigger than the degree of the denominator, it's something. And so you got to go back and look at those rules that we talked about in section 2.6, which is also, by the way, on your purple paper that I just handed you. Your cheat sheet for the test on Friday. All right, number 6, plot at least 1 point in between and 1 point beyond each x-intercept in vertical asymptote. I'll talk about what that means specifically after we actually get to an example. And then number 7, use smooth curves to complete the graph between and beyond the vertical asymptotes. All right, we'll talk about that when we get to it too. So, first example, f of x is equal to 10 divided by x minus 5. Now, you guys, I don't have every single one of these steps memorized, so I'm actually going to maybe need your help in remembering what exactly it is that you're supposed to do first, second, and so on, especially when we get to the examples that are not written out. So, your job, yes?
Can you explain step 7 again?
Step 7 is to just connect your points and make a curve. So step 7 over here would be you look at all the points that you have plotted. These are, we have asymptotes in this graph, so you kind of knowing that there's a point here and there's a point here, and you know that the graph is going to approach that line and approach this line, you kind of make a good guess that the graph is going to curve like this one right here. Okay? Same thing that's happening up here. We had a couple points plotted over here. When that happens, you know the graph is going to approach either one of those. I think you'll see it once you actually try an example. The first thing that you need to do is simplify it. Step number 1, simplify it. Can you simplify 10 over x minus 5? Can't simplify that, so I just said, step number 1 can't be simplified. Step number two, your step number two is to find your y-intercepts, and you find y-intercepts. What did it say you had to do to find y-intercepts? You had to replace all of your x values with 0. So I have 10 divided by 0 minus 5. Well, 0 minus 5 is
-5.
-5, so we have 10 divided by -5, which is -2. There's your y-intercept. So your y-intercept is at the point 0, -2. So I go over here to the graph, and I put a point right here at 0, -2. We know that the graph is going to go through that point. The next thing I need to do is find any zeros that the numerator might have. Zeros are the values at the top that make the top equal to 0. So in this case, because we have a constant number on the top, there are not going to be any zeros. That's a huge clue to you guys. If there's not any zeros, it doesn't cross the x-axis, which means there's a really good chance that you're going to have a horizontal asymptote there. And you guys will recognize in just a minute that there is going to be a horizontal asymptote there. All right, the fourth thing that you need to do is find any vertical asymptotes. So you look at your simplified expression. Well, your simplified expression happens to be the original function. Are there any values of x in the denominator that would make it 0? What could I put in for x in the denominator to make it 0? 5. So that means that you're going to have a vertical asymptote at 5. So I go over here to 5, I go over here to an x value of 5, and that's why I drew my dashed line right there. You guys with me there?
Yeah.
Horizontal asymptotes. Horizontal asymptotes. Well, the degree of the numerator, I wrote here, the degree of the numerator is less than the degree of the denominator. And if you go back to your notes from section 2.6 or from your purple papers right now, if the degree of the numerator is smaller than the degree of the denominator, there's going to be a horizontal asymptote at y equals 0. So let's talk about that for a minute. Go back to your original function. The degree of the numerator. What is the degree of the numerator? The numerator is 10. What is
0.
the degree of that? The degree is 0. Very good. What about the degree of the denominator?
1.
1. So the degree of the numerator is 0. The degree of the denominator is 1. Therefore, 0 is smaller than 1. So you have a horizontal asymptote at y equals 0. Are you with me? I said that really fast. Am I talking really fast?
Yeah.
Okay, I'm going to slow down a little bit. Okay. The next thing that you need to do, step number 6, is you need to find some other points that will work. I know that I have a y-intercept right here at an x value of 0. I also know that I have a vertical asymptote at 5. So what I'm going to do is check a point in between my x value of 0 and my x value of 5. It doesn't matter what you pick, just pick something in between them, okay? So when I pick a value, what did I decided to try an x value of 3. So all I did was I went back to the original function, you plug in a 3, so you have 10 divided by 3 minus 5. Well, 3 minus 5 is -2, so you have 10 divided by -2, which is -5. So I knew that when x was 3, I had a point right down here at -5. Do you see how I knew then that my curve had to look like this? Asymptotes are lines that graphs approach. So I knew that because I had a horizontal asymptote at 0 and then a vertical one at 5, I knew that my graph was going to approach both of those asymptotes. The next thing I need to do is check out what happens on the other side of 5. So I tried what I picked. I picked 6. Well, f of 6 is equal to 10 divided by 6 minus 5. Well, 6 minus 5 on the bottom is 1. So I really have 10 divided by 1, which is 10. So when x is 6, my y value is 10. So when I go over here to 6, I go up to 10, I put a point. I know that my graph is going to exist right up in here. And probably what I should have done, or if you need to, is try, well, what happens when x is, say, 8? Well, if x is 8, we would say f of x is equal to 10 divided by 8 minus 5, which is equal to 10 over 8 minus 5 is 3. So 10 divided by 3 is 3 1/3. So So I know that if x is 8, I have a y value of 3 1/3. So I go over here to 8, I go up to 3 1/3, and we'll say I'm obviously drawing this very freehand right now. We have another point about right here. Well, remember, this is an asymptote. So again, this graph is going to approach that asymptote. It's going to look like this. Yeah.
So you just randomly choose a number?
I do. I didn't randomly, kind of randomly, but not totally. I knew I had a y-intercept here at an x value of 0. I knew I had, so I wanted to figure out what was going on between an x value of 0 and then my vertical asymptote. Okay? And then I also, and if that's not enough, if you can't figure out what's going on in your graph with just those few values, pick something else. Pick a negative x value over here. Plug it in and see what you get. All right, and then we tried some x values on the other side of our asymptote too. Okay, so it's just you could pick lots of points if you wanted to, but I think after you pick a few, you'll have a really good idea. Those asymptotes help a lot. They give you a lot of direction about what your graph is going to look like. Okay. Anything I can clear up here? We're going to move on to another example. You have the example written in your notes, and we're going to follow the steps. F of x is equal to 2x squared minus x divided by x. Get that down, please.
Ready.
Step number 1 is to do what? What are your directions say to do?
Simplify.
Simplify. So help me. What can I do here? Take an x out of the top. Very good. So when I simplify this, f of x is going to be equal to, I can take an x out of the top, leaving me with then, if I take an x out of the top, I'm going to have a 2x left.
Minus 1.
Minus 1. Very good. Divided by, on the bottom I have an x.
X.
What just happened?
Simplify it.
I simplified, but what can I do now? Cancel out the x's. The x in the top, the x in the bottom cancel out. All I'm left with is 2x minus 1. You guys, what is that? 2x minus 1, what is that?
Perfect.
It's a line, yeah. We're going to graph a line. That's huge. Just pay attention to what you end up with, because that's huge. You have a really good idea what's going on with that. But I want to walk you through all the steps so that you're comfortable knowing what to look for. Step number 2. Step number 2 was to replace the x's with zeros. Remember, you had to go back to your original function. Do you remember that?
Yep.
So you replace x's with 0. What's going to happen? You're going to have 2 times 0 squared minus 0 divided by 0. Uh-oh. Equals what?
Nothing.
Equals nothing, yeah, because 2 times 0 squared is 0 minus 0 is 0 divided by 0. You can't have 0 on the bottom of a fraction. So what does that mean to you? Undefined. Yep, you know that your function is going to be undefined when x is equal to 0, which in this case means that there is no y-intercept. There's no y-intercept. What is step number 3?
Find the zeros.
Find the zeros, okay? And we find the zeros by looking at the numerator.
Yeah.
Just the numerator. So, and you can use your simplified expression here. So just use your 2x minus 1. And what you're going to do is put 2x minus 1 equal to 0. Solve for x. What do? Add 1. Add 1 to each side. So 2x is equal to 1. You divide both sides by 2. So x is
1/2.
equal to a half. That means we have a 0 at 1/2. And I'm gonna start graphing here too. We should be graphing as we go here. We know we don't have a y-intercept. We know the graph is not going to cross the y-intercept. We do know that we have a 0 at 1/2. So I'm gonna go up, here's 1. A half would be about right here. So I'm gonna put a point right here at 0. Don't have a y-intercept, so I can't graph anything there. What is step number 4?
Find the zeros of the denominator.
Yeah, so
Would be
after
eight.
find the zeros of the denominator. You guys, these x's canceled out, and all we are left with is 2x minus 1. When you guys, do you remember what happens when you cross off x's when there's a matching factor on the top with the bottom? What did that mean to you? When you could, there was going to be a hole. Very good. Does that make sense? So since I could cross these off, these x's right here were common to the top and the bottom. That meant that there's going to be a hole. There's going to be a hole at the value of x that would make that thing 0. So what is the value of x that makes this 0? 0. It's going to be a hole at x equals 0. So I go to an x value of 0. Here's an x value of 0. And I know that wherever it should cross the y-axis, it's not going to. There's going to be a hole there instead. So we do 2 times 0 minus 1. What's 2 times 0 minus 1? Negative 1. Hold on. I'm not speaking right now. Right. Okay, never mind. I'm sorry. Don't do this. We're looking at vertical asymptotes. I'm sorry. I lost my train of thought there. Vertical asymptotes. We're trying to find vertical asymptotes. We know that there is not a vertical asymptote because there's nothing left on the top, or there's nothing left on the bottom. It canceled out. We know that there's a hole there. We just have to figure out where is our hole going to be. Well, that's the y-intercept. The hole is going to be at the y-intercept because we know that there's a hole when x equals 0. What is our y-intercept? Look at this line. What is the y-intercept here, guys? It's right here. Negative 1 is going to be your y-intercept. So you go down here to negative 1. You put a hole right there at negative 1.
That's true.
Step number 5. Step number 5 is to find any horizontal asymptotes. So horizontal asymptotes. We have to check out the degree of the numerator divided by the degree of the denominator. The degree of the numerator is what? The degree of n of x is equal to 2. What about the degree of the denominator? The degree of the denominator is equal to 1. The degree of the numerator is bigger than the degree of the denominator. What do your notes say about that? Yeah, that means that there's going to be no
Solution.
There's going to be no horizontal asymptote. So we have no vertical asymptote. We have no horizontal asymptote. The only thing that we have going on here is that we're going to have a hole in our graph at an x value of 0. The sixth thing that we need to do, what is the sixth thing that we need to do? I can't remember. At least one point in between the asymptotes. Do we need to do that? We don't have any asymptotes.
Oh.
We don't have any asymptotes in this graph, so number 6 in this case is not necessary. We know that there's a hole here. We know we have an x-intercept right here at 0.5. We also know that we have a line. This 2x minus 1 was a line. Do you guys know where your graph is going to go? Step number 7 is to actually finish this. Where's your graph going to go? It's a line. Yeah, it's going to go through those 2 points. You just need to make sure when you get right here, there's a hole. There's a break in the graph right there. So it's a line with a hole in the middle. more example. Yeah.
So what are we writing 7?
For number seven, I'm sorry, I should have done up here was the graph, was making the graph.
Oh, okay.
Just to make
For
sure, yeah.
5, why is there no? For 5, why is there no? Oh, 4 times.
The degree of the numerator is 2, and the degree of the denominator is 1.
It's more. Okay.
Yes, the numerator degree is bigger than the denominator degree, so there's no horizontal asymptote. Okay. One more example.
Alright.
F of x is equal to x squared minus 36 over x squared plus 3x minus 18. First thing that you need to do is simplify. So let's do that. Simplify. Alright, and when you simplify, that means you need to factor the top and the bottom. So what does the top factor to?
X minus 6.
X plus, yeah, we have the difference of squares. X squared is a perfect square, so is 36. So we have x plus 6 and x minus 6. And then on the bottom, we have, what two numbers multiply to give you negative 18, and when you add them together, they get you 3.
6 3 and 6.
Yes, yes, yes. So we have x plus 6, and we have x minus 3. Is there anything alike on the top and the bottom that I can cancel out?
Positive
Yes,
6.
there is. Okay, so I can cancel. What does that mean to you? As soon as I cancel them out, it means what? It's going to be a whole at x equals 6. I'm going to make a note of that right now. Whole at, actually I just said x equals 6, but that's not what I meant. There's a whole at x equals at negative 6. Because when I put a negative 6 in for x, that's what's going to get me 0 on the bottom. Alright, so when I simplify this, f of x is equal to x plus 6, x minus 6 times, oh my gosh, you guys, divided by x minus 3. I'm going to rewrite that so it looks nicer. X minus 6 divided by x minus 3. Okay. Step number 2. Step number 2 is to find the y-intercept, which means that we need to replace our x's with 0 back in our original function. So we're going to go back to the original function, which is going to get me 0 squared minus 36 divided by, on the bottom, 0 squared plus 3 times 0 minus 18. And the more you guys do this, the more you're going to realize that really all you're doing is just taking the constants, the numbers that don't have the x's, and dividing them. So you're just taking negative 36 divided by negative 18. What is that?
2.
It is 2. So if I'm going to start graphing this, which I'm going to, in other words, what I'm doing right now is I'm starting part 7 right now. I have a y-intercept of 2. So I'm going to go to 2. I'm going to put a point. Step 3. What is step 3? So you have to find the zeros of the numerator. Okay, and you can use your simplified expression for this. So if my simplified expression right now is equal to x minus 6 divided by x minus 3, we are only looking at the x minus 6. So what value of x would make the numerator 0? 6. So my x value of 6 is going to be my 0. So I go over here to 6. I'm going to just ballpark it here. Ballpark value of 6 right here. I'm going to put a point there. The fourth thing that I need to do. What is the fourth thing I need to do?
V.
Can I find the ha right now?
The VA.
The VA. Okay, yeah, VA. So you're right. So step number 4 is to find the vertical asymptotes. In the vertical asymptotes, again, you look at your simplified expression. So I'm gonna say, okay, well, f of x, remember our simplified expression was x minus 6 divided by x minus 3. So what value of x will make the bottom of this thing equal to 0? X is equal to 3. What does that mean to you? When x is 3, we have a what?
Negative 3.
We have a vertical asymptote. Yep. So that means you have a vertical asymptote at 3. So I go to 3. Here's 3. You're going to draw a vertical line. Step number 5 is to find the ha. The degree of the numerator is 2. So the degree of n of x is equal to 2. What about the degree of the denominator? It is also 2. Since the degree of the numerator is the same as the degree of the denominator, what does that mean to you?
You take the lead coefficient.
The lead coefficient divided by the lead coefficient. Good job. So the lead coefficient divided by the lead coefficient, in this case is what?
1.
Yeah, the lead coefficient is 1, the numerator is 1, denominator is 1, so we have 1 divided by 1, which is equal to 1. So you go up to 1 on the y-axis. What are you going to draw there?
Horizontal.
A horizontal asymptote at y equals 1. Alright, and then step number 6. This is where we have to start trying some other values of x. So where should we try some other values of x? We have a vertical asymptote at 3. We have a y-intercept when x is 0. So what should we do? Let's try next value of 2. Sounds good. So I am going to plug a 2 into, you can plug your values into your simplified expression. So when x is equal to 2, I'm going to do 2 minus 6 divided by 2 minus 3. What's 2 minus 6?
Negative 4.
Thank you. 2 minus 3 is negative 1. You divide those, you get 4. So when x is 2, the value of the function is 4. So I go to 2, which is right here, and I go up to 4. Do you see what's going on? Can you tell what's going on with your graph? You have a horizontal asymptote here. You have a vertical asymptote going this way. You know that those are lines that the graph is going to approach, and you have a point here and you have a point here. You know your graph is going to do. Now we just need to figure out what's happening in between 3 and 6. Do you understand why I'm picking points between 3 and 6?
Yeah.
We have a vertical asymptote at 3, we've got a 0 at 6. I have a pretty good idea what's going to happen here, but let's try one more value. What do you want to pick? Something between
4.
3 and 6. 4? 4 or 5? Let's do 4. Let's do 4. So, when x is equal to 4, we have 4 minus 6 divided by 4 minus 3. What's 4 minus 6?
Negative 2.
Negative 2. 4 minus 3 is 1. So you end up with negative 2. So when x is 4, y is negative 2. So I go over here to 4. I go down to a y value of negative 2. We put a point. You have asymptotes going on there. You've got a couple points. Make a good guess. Actually, it shouldn't be a guess. Graph is going to do this. And if you need to, try more values. Try 5, try 8, try 10, try 100. See what happens. How do you feel? It's freezing. How do you feel about the math?